This is problem 48 from chapter 4 in the homework, in the textbook. So this actually talks about the amount of sunlight that a location has per day is of interest in the use of solar power for creating electricity. The data set has the amount of daylight hours in Finland in a year. So we have the date, it's actually the date of the year. We have the day, because dates are hard to work with. We went ahead and calculated the day it was. And then we have the length of daylight hours for those days. We like to use technology to create a scatter plot of this data. We're going to actually use Desmos for this. Oops. Where's my Desmos? Sorry about that. There's my Desmos. Okay. So we're going to use Desmos for this. I'm going to go ahead and just reload Desmos. So you got desmos.com/calculator that you would use. I can actually take this data, copy it using either Control-C or Command-C, depending on if you're Mac or PC or Mac that is. Over here, I can paste it in there with either Control-V on PCs or Command-V on a Mac, and it puts my data in there. The nice thing is it also figures out exactly what the window should be set up to match it. Now, looking at this, it looks like it goes up and comes back down. So it looks like it's parabolic or quadratic in form. However, one of the things I got to think about is that this is the number of daylight hours in a year. Next year, it'll look just like this. The year after, it will look just like this. It's not going to change. So it's going to keep repeating itself over and over and over again, forever and ever and ever. So this isn't actually quadratic. This is actually parabolic. So we actually will be modeling with a parabolic. I would like to now use technology to create an appropriate model for the length of daylight hours. I want to go back to my modeling to find out what that equation looks like. So at the start of modeling in the textbook, there's actually a description of what all the different models are we use in this class. There are lots of other models, but these are the main models we're using. And we're looking at periodic. And periodic has this form, y is equal to a times the sine of bx plus c plus d. So what I do over here is y1 is my output variable. So I'm going to use y, and if I just type y and then a 1, it automatically puts it as a subscript. Instead of an equal to, Desmos uses a tilde to say that's how it will notify the model. And then I'm going to start typing my model. My model is a times, and my times is the star above the 8. The sine, I just type SIN for sine. Then parenthesis b x plus c. But I don't want just x because my variable is actually x1 for my input. So again, I need to put a 1 and then plus d at the end. And now when I look at this, I can see how nicely it actually plots up quite nicely. That line, that graph actually models my data. It then gives me my parameters, my A, my B, my C, and my D. So I can now come back into my function, my problem. And you can write this anywhere you want, but I'm going to type it here next to where the problems I'm working with. And so what I have now is I have y is equal to and I've got my A, and I probably do that as 6.3. I don't need to make it a whole long thing. Sine of B, my B is 0.017. You don't want to just round it off to 2 decimal places because that's not a very big number. So a little bit farther on this case is good. X plus C, my C is actually negative 1.33. So instead of putting a plus, I'm going to do plus a negative, which is just minus a 1.33. Close that, and then plus my D, and my D is 12.2. So there's my model that models this data. It then asked me to determine the R-squared value. As opposed to the calculators, Desmos will always calculate R-squared value. The R-squared value is right here. It happens to be 0.996. That means 99.6 of the variability in the length of daylight hours is explained by the model that we just came up with. I then would like to use the model to estimate the daylight hours 160 days into the year. I can actually copy my equation that I just typed in, or you can type it into Desmos or your calculator. I can actually paste it in here. I do want to change my X to the X value I have. My X value I want to do is for 160 days. So I'll put my X value of 160 days. It tells me it's 18.4. So I now know that there's 18.4 hours of daylight on that 160 days into the year. It wants to know, should the estimate be trusted? And 160 days falls within the original data. In fact, here's 151 and here's 181. So even though 160 days isn't one of my data points, it does fall in the range of the original data. So therefore, it should be trusted because it works out. And in fact, if you look at this, 18.4, 151 was 18.35, 181 is 18.78. So 18.4 falls right in those values. So yes, it should be trusted.